Welcome to today's lesson on prime factorization. Today you will be learning how to find the prime factors of a number, and then you will learn how to put them into an equation using exponents. Before we begin today's lesson, let's go over some basic vocabulary. First, let's discuss factors. What exactly is a factor? A factor is a number you multiply by another number to equal a product. So if we multiply the number 2 times the number 3, we get a product of 6. The two factors in this problem are going to be 2 and 3, because those are the two numbers that we're multiplying together. Let's try another one. If we multiply 3 times 4, we get a product of 12. Once again, the factors in this problem are going to be the numbers that we're multiplying, which in this case are 3 and 4. All right, let's go ahead and discuss prime numbers. What is a prime number? A prime number is a number that only has two factors. So if we multiply 2 times 1, we get a product of 2. The number 2 can't be multiplied by any other number to get a product of 2. So that means that 2 is prime. Let's look at 3. 3 times 1 equals 3. Can you think of any other factors for the number 3? No, because there aren't any. So that means that 3 is also a prime number. How about the number 5? 5 times 1 equals 5. 1 is the only number we can multiply 5 by to equal 5. So 5 is another prime number. There are a couple of basic prime numbers that you should become familiar with. 2, 3, 5, 7, 11, 13. Those are the traditional prime numbers that you're probably going to see often. Our first step in prime factorization is finding the prime factors of a number. So what I'm going to do, I'm going to show you two different strategies that you can use to find the prime factors of a number. Let's go ahead and start with an example using 36. We're going to find the prime factors for the number 36. This first strategy is called upside down division. It looks like you're doing division, but just like the title, it looks upside down. So we're going to start by drawing the division symbol upside down. Now when doing upside down division, you first have to divide the number by the lowest prime number available. So since 36 is an even number, that means we can divide it by the number 2, because we can't find a smaller prime number than 2. So 36 divided by 2 equals 18. Now I'm going to continue my upside down division symbol and try to divide 18 by the lowest possible prime number. Once again, since 18 is even, that means I can divide it by 2. 18 divided by 2 equals 9. I'm going to continue my upside down division symbol here. But since 9 is an odd number, that means I can't divide it by 2. So my next prime number is going to be 3. 9 divided by 3 equals 3. Once you reach a number on the bottom of your upside down division that is prime, that means that you're finished and you found all of the prime factors for that number. So for the number 36, I have all lined up these prime factors over here already in order from least to greatest. So let's put those in an equation. 2 times 2 equals 4, times 3 equals 12, times 3 equals 36. So what I did, I just took each of these factors, 2, 2, 3, 3, and I put them into an equation to equal 36. 2 times 2 times 3 times 3 equals 36. Right, let's go ahead and look at another strategy to find the prime factors for the number 36. We're going to use the same number again so that you can compare both strategies to each other. All right, this strategy is called a factor tree. What you're going to do, you're going to write down two factors for the number 36. It does not matter which factors you choose. You could choose 12 and 3, 6 times 6, 9 times 4. It doesn't really matter because at the end you will still find the prime factors. So what we're going to do, we're going to start with 9 times 4. 9 times 4 equals 36. Now what we're going to do, we're going to break it down even further and find the factors for each of these numbers. So what are the factors for the number 9? We multiply 3 times 3 to equal 9. When you're doing a factor tree, you're never going to list the number by itself. For example, I would not use 9 times 1. All right, let's look at 4. What two numbers can we multiply together to equal 4? We can multiply 2 times 2. Once you reach prime numbers at the bottom of your factor tree, you're going to circle them. And that means that you are going to stop. You're not going to break these numbers down even further. All right, so now we have our factors, prime factors, that are listed at the bottom. So once again, just like we did with upside down division, we're going to list those factors in order from least to greatest. 2 times 2 times 3 times 3 equals 36. So here we have two different ways that you can break down the number 36 to find prime factors. You did a great job finding the prime factors for the number 36. We're going to do some more practice together. Let's find the prime factors for the number 42. We're going to practice the upside down division strategy first. All right, our first prime number and lowest prime number that we have is 2. And since 42 is an even number, we can divide 42 by 2. So 42 divided by 2 equals 21. Since 21 is an odd number, we can't divide it by 2, so we're going to go to our next prime number, which is 3. 21 divided by 3 equals 7. Since 7 is a prime number, we have now listed all of our prime factors for the number 42. So let's put these into an equation. 2 times 3 times 7 equals 42. All right, now that we've gone ahead and we've done upside down division for the number 42, let's see if we can also find the prime factors using a factor tree. So we're going to put the number 42 in the middle, and I'm going to draw two lines for our starting factors. So if we multiply 6 times 7, we get a product of 42. Since 7 is a prime number, I'm going to circle it because we can't break 7 down any further. So let's focus on the number 6. What two numbers can we multiply together to equal 6? We can multiply 2 times 3. Now once again, we've found prime numbers. So we have found all prime numbers that are factors of 42. So if we write this in an equation, we have 2 times 3 times 7. All right, you're doing great work. Are you ready for one more example? Let's try using upside down division to find the prime factors for the number 50. All right, let's start by putting our upside down division symbol. 50 divided by 2 equals 25. We're going to continue our upside down division. 25 cannot be divided by 2 because it's odd. 25 cannot be divided by 3. So now we're going to move to our next prime number, which is going to be 5. 25 divided by 5 equals 5. So now we have found all of the prime factors for the number 50. If we multiply 2 times 5 times 5, we will get a product of 50. All right, let's go ahead and do our last one. Now we're going to use 50 and use a factor tree to try to find the prime factors again. If we multiply 10 times 5, we get a product of 50. 5 is a prime number, so let's go ahead and circle it. We can't break it down any further, but we can break down 10 even further. We can multiply 2 times 5 to equal 10. And once again, 2 and 5 are prime numbers, so we have now found all of the prime factors for the number 50. So we can multiply 2 times 5 times 5 to equal 50. All right, you have now seen two different strategies that you can use to find the prime factors of a number. Our next step in prime factorization is taking the list of prime factors that we previously found using our upside-down division or factor trees and writing an equation with them using exponents. Let's begin with the number 36. We found that 36 is equal to 2 times 2 times 3 times 3. But that's a pretty long equation to have. So what we're going to do, we're going to shorten this using exponents. So we have two 2's here. So using exponents, we can say that 2 times 2 is the same as 2 to the second power. Now we're going to try to shorten 3 times 3. Once again, we have two 3's here. So we're going to shorten that to 3 times the second power. So we have now said that 36 equals 2 to the second power times 3 to the second power. Let's go ahead and look at another example together. Our next number that we found the prime factors for was 42. We found that 42 is equal to 2 times 3 times 7. Now this is a special case. Since we don't have any repeats of any of these prime factors, we don't need to use any exponents. Because if we used exponents, we would just raise each of these to the power of 1, and that wouldn't shorten our equation any. So actually, this one's already done for us. We don't have to do anything. So lastly, let's look at the number 50. We know that 50 is equal to 2 times 5 times 5. Now, if we're going to write this using exponents, we see that we only have one 2, so we don't have to raise that to a power, but we have two 5's. So I'm going to cross out these two 5's and change it to 5 to the second power. So 50 is equal to 2 times 5 to the second power. Are you ready for a challenge? What I'm going to do is write out an equation for you that I want you to shorten using exponents. Let's go ahead and begin. If you were to multiply 2 times 2 times 2 times 13 times 13 times 13 times 13 times 19 times 19, how would you shorten this equation? Here's where you can really see that exponents would come in handy. Alright, let's go ahead and do this one together. When we're writing with exponents, we're going to first start with the first grouping of numbers. So we would know that we have 2, we have 1, 2, 3 of them. So we would represent that as 2 to the third power. I'm going to go ahead and cross out those 3 2's so that when I write this equation shorter using exponents, I don't repeat. Alright, how many 13's do we have? 1, 2, 3, 4. We have 4 13's. So I'm going to multiply 2 to the third by 13 to the fourth power since I have 4 13's. And once again, I'm going to cross that out and move along to the number 19. I have 1, 2 19's. So I'm going to finish my equation with 19 to the second power. You can see how helpful it is to be able to use exponents to shorten this. Are you ready for another challenge? Do you think that you can do the opposite of what you just barely did and expand or make an equation longer? Alright, if I were to say 3 to the third power times 7 to the fourth power times 13 to the second power, and I asked you to expand it, do you think you could do it? Well, let's see. 3 to the third power means that we're going to multiply the number 3 times. 1, 2, 3. 7 to the fourth power means that we're going to multiply the number 7 4 times. So 1, 2, 3, 4. And 13 to the second power means we're going to multiply the number 13 2 times. 1, 2. You've done a great job so far. So now you can see how you can either shorten an equation using exponents or expand an equation that had an exponents and make it even longer. Let's go ahead and review the steps for prime factorization. We're going to use the number 108 for a sample problem while we're reviewing. So let's begin. Step 1. We have to find the prime factors for the number. So when we're finding the prime factors for the number 108, we can either use a factor tree or upside down division. So let's go ahead and use one of our strategies. In this case, I'll use upside down division. 108 divided by 2 equals 54. All right, now we can divide 54 by 2 since 54 is an even number. So 54 divided by 2 equals 27. 27 is an odd number, so we're going to move to our next prime number, which would be a 3. 27 divided by 3 equals 9. And we can divide 9 by 3 to get a prime factor of 3. So our first step for prime factorization is finding all of the prime factors of a number. Our second step is listing all of these in an equation. So we're going to multiply 2 times 2 times 3 times 3 times 3 to get a product of 108. Our third and final step is to shorten this equation using exponents. So we have 2 2's here, so we say 2 to the second power times 1, 2, 3. We have 3 3's. So we're going to multiply it times 3 to the third power to get a product of 108. So there are 3 main steps for prime factorization. Step 1, find the prime factors. Step 2, write out the prime factors in an equation. And step 3, shorten your equation using exponents.